A very good evening to everyone. Here, today, we go with the discussion of our question paper, which is related to there is an units, measurements, and dimension. As we know that the first question which has been given on the basis of a density of a wood is 0.5 gram per cubic centimeter in CGS system of units. The corresponding value in MKS unit is here. There is a density of a wood is given in CGS. We know that density is always going to be defined as density of any body or any material is given as the density is always given as it's a mass per unit volume, mass divided by volume. So this is we call as a density. And now we have a short trick which is related to the measurement of this density, that is we call as a triangular physics. In this triangular physics, you can just look at this density is equals to mass by volume. If I need to go for calculating the mass, if I going to close this, it's a product of a density into volume. If I need the volume is equals to what? Mass divided by density. So this is we call as a triangular method to remember the density of any material. Here, there is a wooden log is given. There is a wooden log. Like that, imagine there is a wooden log has been given. Such a wooden log has been given. And this wooden log is going to be having certain density. This density of the wooden log will having the density rho is equals to. The density is given. How much is the density of this wooden log is given? It's about 0.5, 0.5. It's a gram per cc. There's a gram per cc. Here cc stands for, this is cubic centimeter. Cubic centimeter. This is called cubic centimeter. Then this value is given in CGS. We have three measurement systems. The first measurement system is called as a CGS. Second is called as EFPS, and third is called as an MKS, and the fourth is called as a universal system, that is called SI system. This is we call as a system of international. Among these three systems, centimeter, gram, second, foot, pound, second, meter, kilogram, second. Now here, this value, whatever is given from one system, this is we call as a one system. From one system to, we have to convert from the another system. Then this is we going to be using the one of the application of a principle of homogeneity. So principle of homogeneity is applied. This is the first principle. This is the first method. And second, we are using the direct method. I will go with the both method. How to solve such a problems? Okay, solution. So solution for this question. Now, here we given the value. So what's the given value we have? The given value or given data is 0.5 gram per cubic centimeter. It's a given value. Then converting this one in MK system, that is meter per centimeter can be converted into what? And a cubic centimeter is converted to what? Cubic meter. How it is? See now. So this is equals to 0.5 into gram. So gram, if you convert in kg, this is equals to, for this 1 gram is equals to, this is 10 to the power minus 3 kilogram. How it is? 1 gram is always equals to how much we can write? This is 1 by 1000. 1 by thousands of this kg we have. This is, we have to convert this. So this is 0.5 into 10 raised to minus 3 kilogram. We got this is in kg. Then divided by, so this is divided by centimeter. So 1 centimeter is equals to 10 raised to minus 2 meters. That is 1 by 100 times of the meter we have. 1 by 100 times of the meter we have. Then substitute here. That can be written as 10 raised to minus 2 whole to the power, because cubic centimeter, this is cube, this is m cube, this is cubic meter, kg per cubic meter. So this is equals to then 0.5 into 10 raised to minus 3 divided by 3 2s are 6, 10 to the power minus 6. This is kg divided by cubic meter, kg divided by cubic meter. Then minus 6 in denominator. If it goes to the numerator, it will become plus 6. 0.5 into 10 to the power minus 3 plus 6. This is kg per cubic meter. Then minus 3 plus 6, it will become plus 3. Hence, this is equals to, density is equals to 0.5 into 10 to the power plus 3. This is kg per cubic meter. Density is equals to, this is 10 cube, 10 to the power 3 can be written as 1000. 1000 into 0.5. We will get this one as a 500 kg per cubic meter. Hence, option number. Look at the option. So this is the option number first. This is the correct one. Then we go to the second method. That is by using the physical quantity. The physical quantity can be given as physical quantity. The physical quantity, as you know very well, this physical quantity of anything that can be easily measurable or it can be easily measurable, that is called as a physical quantity. It is denoted by its capital Q. This is equals to, any physical quantity can be represented as capital Q, and this is equals to, it's a numerical value into unit, numerical value into unit. For any two similar quantity, there is a comparison. If I make two comparison, then what I have to write? So this can be written as, this is Q1 is equals to Q2 for any two quantities. Then this equation can be represented as, this is N1 U1 is equals to N2 EU2. Then this system, see, one system that is given as CGS, we have to convert into, what is that system we call? MKS. How do you convert from this equation? Let's find the method to solve by using this technique now. There is an alternate method. I'm going to showing you how to solve. There is an alternate method. This is the basic method what I showed. And then this is we call as another alternate method by using the dimensional technique here. Then N1 U1. The value is given for this. The value of this N1 we have to calculate. Then N2 is given. N2 is how much? 0.5 gram per cubic centimeter. So that's why here N1 we have to calculate. N1 is equals to, keep it N1 as it is here. U1 goes to the denominator of RHS. This is N2 into big bracket. So this is, we have N2 divided by N1. N2 divided by N1. So therefore, N2 divided by N1 we got. Therefore, N1 is equals to, N2 is how much? 0.5 into big bracket. N2, the N2 is the corresponding quantity which has been given. So this quantity is given in terms of a gram. That is the first system. There is a centimeter gram it is. So this is gram divided by, this is kilogram. This is kilogram into gram divided by kilogram. The next one here, the second value which has been given in terms of centimeter divided by meter whole to the power minus 3. Why it is minus 3 I have included? Because per cubic centimeter. Per cubic centimeter can be written as to the power minus 3. Then simplify this. N1 is equals to 0.5. Then gram divided by, for 1 kg, how many grams we have to write? There is 1,000 grams. For 1 kg, how many grams? 1,000 grams. So this is 1,000 grams. Then here, centimeter, keep it as it is. For 1 meter, how many centimeters? 100 centimeters. So this is 100 centimeters. So centimeter, centimeter will be cancelled. Gram and gram will be cancelled. Then we can write this. N1 is equals to 0.5 into 1 by 1000. 1 by 1000. This is 1 by 100. 1 by 100 to the power minus 3. Then you see 10 to the power plus 3. We can write for this N1 is equals to 0.5 into 1 by 10 to the power plus 3. And then this is 1 by 10 to the power plus 2 whole to the power minus 3. Then simplify this. When power will be in denominator, if it goes to the numerator, it will become negative. Then N1 is equals to 0.5 into big bracket 10 to the power minus 3 into 10 to the power minus 2 whole to the power minus 3. Let's simplify this. N1 is equals to 0.5 into 10 power minus 3 into 10 to the power minus into minus plus 3 to 6. When bases are same, power must be added or may be subtracted. N1 is equals to 0.5 into 10 power minus 3 plus 6. Then N1 is equals to 0.5 into 10 to the power plus 3. N1 is equals to, this is 500 kg per cubic meter. So this is the excellent answer. So just remember, this is the system where we are going to be using. Okay, go for the second question. In the second question, if U1 and U2, remember U1 and U2, U represents there is an unit. U represents what? And a unit. And as you know very well, the physical quantity, whatever we are measuring, or any physical quantity we are measuring without a unit, a number is meaningless, and number without a unit is meaningless. It means both are compulsory. Writing the unit, physical quantity, physical quantity, that is Q, is equals to, we know that numerical value into numerical value into an standard reference. The standard reference is called as a unit. Standard reference is called as a unit. Then physical quantity is denoted as Q is equals to numerical value is given as N. Unit is denoted as U. So this is a physical quantity can be represented. Then here U1 and U2 are the two units of a given physical quantities are given. How we can express this? As I taught earlier, that is for two similar physical quantities or the two quantities can be represented. Q1 is equals to, this is N1 U1 and similarly Q2 is equals to N2 U2. For comparison of these two, for similar quantities what we get? So Q1 is equals to Q2. Then we can write this as N1 U1 is equals to N2 U2. From this relation, we can also come to know that number is inversely proportional to unit. This. Okay? The next question. You go for the third question there. In the third question, the equation of a wave is given by. We know that for equation of a wave is always defined as a wave. Wave means sort of disturbance in a medium. Medium is called as a wave. So that is wave is nothing but what? If I disturb any medium, that medium will produce a wave. Imagine if we have a still water in a cup, which is going to be kept on a table. Okay, imagine this is a cup of tea we kept. Okay, so here there is a water, or imagine there is a hot tea will be kept. Okay, then which is placed on a table. It is placed on a table. Then on the table, if I going to be just give a plug all the disturbance to this cup, what will happen? There is waves are going to be produced like this. This is nothing but what? Disturbing the medium. The energy will be carried out over here. There is an energy. Sort of disturbance. If I going to be hit the board by knocking the door, see, there is a sound will produce. Sound is also called as a wave. There is a disturbance due to there is a collision between the molecules of the given medium that produces a wave. So this wave, so the motion of a wave is propagated. The propagation of a wave is represented by the equation y is equals to, propagation is nothing but what? There is a movement, or there is a transmission, or there is a move, or there is, we can call as a transportation. Y is equals to a sine omega into x by v minus k. This is called as a progressive wave equation. Remember, this concept will be discussed in the last chapter of PUC first year. That is called as a wave chapter. In that wave chapter, one of the important equation that is called as a progressive wave equation. What is a progressive wave? A wave which travels continuously in a medium is called as a progressive wave with constant amplitude and a phase. Okay, then A stands for amplitude. Y stands for displacement. Sine stands for function. Omega stands for angular frequency or angular velocity. Then K is called a propagation constant. And here, amplitude of a wave. See, this is we call as a typical wave diagram. So here there is a maximum displacement. We can observe the particle over here about the positive and negative y-axis. This is we call maximum displacement of a particle. Remember, maximum displacement associated with the particle is called as a amplitude. This is called positive amplitude. This is we call as a negative amplitude because it is going to be obtained in negative y-axis and this is at positive y-axis. And the wave is propagating towards positive x-axis. So this is positive x-axis. Then here negative sign indicates the wave is propagating along positive x-axis. Okay. Therefore, now this is a given condition, and everybody is thinking that what is this angular velocity? Angular velocity omega is equals to angular displacement by time taken. Angular displacement divided by time taken is called as a angular velocity. Angular velocity. So imagine a particle is moving in a circle. So this is the point we call as the O. Then here there is a particle will be obtained. See, this is O, A, B. Particle starts its journey from the point A. This is we call as a radius. This is we call as a radius. And this is completely we call as a diameter. Therefore, as the particle will cover certain distance, and this part is called as angular distance. This is called as angular displacement. Angular displacement always measured in radians. It is measured in radians. Because as you know very well, the 7 base fundamental quantity, among the 7 base fundamental quantity, we have remaining 2 are called as supplementary quantities. Among those 2 supplementary quantities, one is called radian, another is called as a steradian. One which measures the plane angle, this is we call as a plane angle, another is called as a solid angle, that is the steradian. Okay, here this point which will be represented as angular. The time taken to reach from the point A to B, that is t. And the velocity is given as, this is theta by t, angular velocity. Then finding difficulty again. This is we call as angular velocity. When it is moving in circle, then if it moves on a straight road or if it is moving on a straight path, that is what you call linear velocity. Linear velocity is equals to displacement by time taken. Don't get confused. So this is angular, this is linear. Okay, linear is nothing but what, like this. A car is moving. See, a car is moving on a straight road. This is called linear. A pebble which is going to be tight and is going to be reeled in a circle, which is going to be reeling in a circle. This is we call as an angled movement. It is okay. Therefore, now according to this question, you see the question there, where omega is called angular velocity, v is the linear velocity. Yes, of course. Where v is going to be called as what? Linear. Okay, linear velocity. Then the dimensions of a k is, as apply the principle of homogeneity. As you know very well, the principle of homogeneity states that what? The principle of homogeneity states that, as you proved in the earlier class, the principle of homogeneity states that LHS of any physical equation is always equals to RHS. This is we call as a principle of homogeneity. And we have plenty of questions we have been solved on the basis of principle of homogeneity. Among those, 3 are the best examples we gave. The 3 best equations are the equations of motion. V is equals to u plus at, v square minus u square is equals to 2as, s is equals to half at square. These are the best examples we have. Among those equations we call as the principle of homogeneity. Apply the same situation. Then you see, and this is the part which is going to be kept constant. And we need to be find out by using the value of this k. Then apply this, we get x by v minus k is equals to 0. Then x by v is equals to k. That's all. By applying the homogeneity constant, then find out the dimension associated with these physical quantity. X is called displacement. X is called as what? Displacement of a given wave. Displacement. Displacement is always measured in terms of meters. This will be given as meter. Meter is the unit to measure what? Length. We got the dimension as a length, L. Velocity, which velocity we have? Linear velocity. Linear velocity. Linear velocity. Linear velocity is given in terms of what? Meter per second. Velocity is given as meter per second. And meter is the unit to measure what? Length. Second is the unit to measure what? Time. This is L t power minus 1 we got. Then, once we got these 2 values, the fundamental values we got, converting the derived quantity into a fundamental. So this is we call as the conversions. Once the conversion is over, you can substitute the corresponding value in a given physical equation. That's all. If I substitute, what I get here, the constant value k. This is called propagation constant. K is equals to. What is the x value we got? Length is L. So here is the L. whole divided by L t power minus 1. L t power, this is minus 1 we got. Then simplify this. This will be L plus 1, L minus 1, t plus 1. Why? Because power will be changed. This is plus 1. It goes to numerator, it become minus 1. So this is equals to, when bases are same, power must be added or maybe subtracted. So this is from the log indices. Then we can apply for this. That is L to the power plus 1 minus 1 t power plus 1. Then plus 1 minus 1 will be cancelled, and this is equals to L power 0 t power 1. If I write or leave it, no problem for this. And this will be equals to like this. And 10 to the power 0 is equals to how much? 1. Don't make it confused. 10 to the power 0 is 1. 10 to the power 1 is 10. Okay, similarly, L to the power 0 is 1. We can write for this 1 into t. This is equals to t. Option number. You can judge the correct answer. Okay, it's option number 2. Okay, we go for the next question. You see the next question? If velocity v, acceleration a, and a force F are chosen as a fundamental quantities, then the dimensional formula for angular momentum in terms of VAF would be. Okay, so there is a solution. Angular momentum. You know that angular momentum always denoted by it is denoted by capital A. You remember, it's a capital A. And this angular momentum always a vector quantity. Vector quantity. It's a vector quantity. What is a vector? You know very well. A vector is the one, it has both magnitude as well as the direction. In vector notation, it can be represented as vector L is equals to mass is the scalar physical quantity. It is a scalar. Only magnitude, no direction for the mass. M V cross R. This is we call as the notation of an angular momentum. L is equals to mvr. M is the mass associated with the body. V is the velocity associated with the moving particle. R is the corresponding radius. Okay, and now we can write this. L is equals to, this is mvr for maxima. For maxima, we are talking about the corresponding angle should be 90 degree. Sin 90 is always maxima. Sin 0, it's 0. That's why this whole quantity will become 0. For maxima, theta is equals to 90 degree. Then, mass measured in terms of kilogram. Mass is measured in terms of kilogram. Velocity measured in terms of meter per second. Radius, that is measured in terms of meter. So this is we given as this is kg meter square per second. So this is we call as an angular momentum. We call as a angular momentum. And we have 7 base fundamental quantities. Those 7 base fundamental quantities. How do you remember those 7 base fundamental quantities? Yes, we have a short trick for that. To remember the 7 base fundamental quantities. How it is? See, this is L, M, T, E, T, L, A. Like that you should remember. LMT, LMT, ET, LA. You remember in this situation, there is a shortcut technique. Length, mass, time. electric current, temperature, luminous intensity, amount of substance. These are the 7 base physical quantities there we have. Okay, among them, kg is the unit to measure what? Mass. I can write this as a fundamental. This is we call as a derived quantity. Derived quantity. Converting derived into a fundamental. So this is angular momenta. L is equals to, this is kg, can be given as capital M. How many kgs are there? Only 1 kg. That is m to the power 1. Then how many meters are there? 2 meter quantities. That is L to the power plus 2. How many time quantities we have? Only 1. That is the t power minus 1. Yes, we got there is a dimension of this. Similarly, now this quantity we have to express. You read the question carefully. We have to express these quantities in terms of V, A, and M. It means angular momentum L is directly proportional to V, A, M. Among these quantities, we have to find the values, because the values we don't know. That's why we are going to be using the dimensional method there. Okay, remove this proportion value by putting some constant. What the constant we can get? L is equals to, there is a constant will be written as capital K. The dimensional analysis is failed to give the values of any trigonometric function. Dimension we can't give for trigonometric function. It's the biggest failure. Second one, there is a dimensional analysis we can't apply for the constant. That's why for constant we can't put any dimension for that. Okay. Then here, velocity, and we know that velocity is equals to what? Meter per second. Meter is the unit to measure what? Length. Second is the unit to measure what? Time. This is L t power minus 1 we got. Substitute over here. L t power minus 1. Then acceleration. For A stands for what? Acceleration. A is equals to meter per second square is the acceleration. Meter is the unit to measure what? And a length. Second is the unit to measure what? Time. This is the t power minus 2 we got. Then this is power A. For this power will be B minus 2 to the power B. And force. Force is equals to what? F is equals to what? Mass into acceleration. According to Newton's second law, it's a product of a mass into acceleration. It's a product of a mass and acceleration. That is called as a force. Then force is equals to mass can be given as kg. Acceleration is given as meter per second square. This is kg meter per second square. Kg can be given as 1 in mass, 1 in length, minus 2 in time. So this is the dimension of a force. We got the force dimension. Then substitute here force dimension. 1 in mass, 1 in length, minus 2 in time. This is the dimension we got. Of course, we calculated the dimension of angular moment also. The dimensions of angular moment over here. The dimensions of angular momenta is m1 L to the power plus 2 t power minus 1 is equals to k into L t to the power minus 1 to the power a. L t to the power minus 2 to the power b, L to the power 1, L to the power minus 2 to the power c. Of course, then there is a small mathematical steps. We have to apply the mathematics to solve this method. Okay, then simplify this. K into L to the power a, t to the power minus a, because this power will be multiplied over here. Then L to the power b, t to the power minus 2b. Then m to the power c, L to the power c, t to the power minus 2c. Then similar term, make it one side. How many masses we find? Only one mass. That's all. So this constant will have to be eliminated. No need to be written over there. Therefore, m to the power c over. Then how many L's are there? See how many L's we have over here. This is the first L, second L, and this is the third L. Then take this all L one side. L to the power. What is the sign over? We have plus L to the power A. This is again plus we have. So plus B, and how many C will be there? Plus C. Then A plus B plus C we got. Then next one we have how many times we have. So this is the 1, this is the 2, and this is the 3 times we have. T to the power minus A minus 2B minus 2C. We got all the values over here. Then compare with this RHS value. Then first we compare with mass. M power 1 is equals to M power C. When bases will be same, according to principle of homogeneity and principal concept we have to apply, then the value of C is always equals to 1. That's all. Then compare with the L value. Compare with the L value, what you get now? See, L to the power. So how many L values you have? There is a 2. There is a plus 2 we got. This is equals to A plus B plus C. L to the power A plus B plus C we have. Then simplify this. This is 2 is equals to A plus B plus C. Then what is the value of C? We have 1. Substitute over here. 2 is equals to A plus B plus 1. Then A plus B is equals to 2 minus 1. This is equals to 1. We got there is an value is equal to A plus B is equals to how much we got? 1. Similarly, now here we go with this value here again for the corresponding T value. This is T to the power minus 1 is equals to T to the power minus A minus 2B minus 2C. This is minus 1 is equals to minus A minus 2B minus 2C. Minus 2C we got. Therefore, C value is how much we have? 1. Substitute minus 1 is equals to minus A minus 2B minus 2. That's all. Then once you simplify, you get all the values as a is equals to, as the final answer, we can get the corresponding value is A is equals to F. If I going to be option number 2, we get the option number 2 it is. Okay. Hope you can continue the remaining things there. Because there's the mathematical steps, you can just compare the equation, you can get the answer. Okay. There's a comparison will be there. That's all. Then in the question number 4, you can just look at the question number 4. In the question number 5, what you have? A physical. In the question number 4, the option number 2 is the correct answer. Just you look at the condition, whatever I wrote over here. So this equations, you have to solve that, you can get the answer there. And then you can substitute the values there like this. Force here is directly proportional to what that. So there is an angular momentum of a given equation is given as the angular momentum of a given equation as given that is L is equals to, this is K into, that is we got the value as a B, this is A and this is here. So this is A, B, C. That value we got that. And once you substitute all values, you can get there is a 1, 3 and minus 2. Hope you get the conditions clearly there. Then the next question, a physical quantity that has a physical quantity X depends on the quantity Y and Z as follows. X equals to AY plus B tan CZ. X equals to AY plus B tan CZ. So this is where A, B and C are called as a constant. A, B and the C. A, B, C are called as constants. These will be constant. And apply the dimensions of B is always equals to, here the dimensions of B is always equals to, remember the question what we have, the dimensions of B is always equals to the dimensions of AY, the dimensions of AY. Once you look at the condition, whatever is given here, so once the dimensions of B is always equals to the dimensions of AY, then we can write this B is equals to what again? AY. Then find this value of Y is equals to what? B by A. The first condition we got. Similarly, and to find the X value also. X value is always going to be equals to what? The X value is same as to that of the dimensions of X will have the dimensions same as that of AY. Hence, the answer will be option number 3 is the correct one. Option number 3 is the correct one. Then question number 6. Here we have a physical quantity. A physical quantity which is given as the P, and the P is equals to the physical quantity value is given. Then P is equals to what is given? P is equals to A to the power 3, B to the power 1 by 2 whole divided by C to the power -4, D to the power +2. Then the quantity which brings the maximum percentage error in P. For maximum percentage error, we know that from the quotient rule, from quotient rule, percentage error of this given physical equation can be given as delta P by P into 100 is equals to delta P by P into 100 is equals to power will be 3 into delta A by A into 100 plus 1 by 2 into delta B by B into 100 plus power -4. Then it will be in errors, it will be eliminated, negative sign will be eliminated. So this is 4 into delta C by C into 100. Then plus this is 2 into delta D by D into 100. Look at this. Which is the maximum power you can find, at the maximum error we can find the maximum value which is equals to this. Where you can find the answer will be C. The error which can be found, maximum percentage error in C only. Guys, we have in the next 15 minutes, there is a doubt session will be there. If you're going to be having any doubts regarding with the whatever the question I will solve over here, and you can ask the question over there. Yes, sir. There is a question we got, sir, what is the meaning of that omega? So this omega is called as a angular frequency or angular velocity. The meaning is what here? Angular velocity. Omega is always called as a angular velocity. Angular velocity. Okay, angular velocity of a given particle. For example, I will say now there is an, if I am going to consider a particle is moving in a circle, a particle is moving in a circle. If it starts a journey from the point A, imagine this is the journey which is going to be started by the particle from the point A. Then, if it moves from point A to B with certain distance, okay, this is the corresponding value. It moves from here. Then it covers certain distance. So this is called as the angular distance it is. Then this is we call as a theta. The time taken to reach from point A to B is called as a t. Then this is going to be expressed as angular velocity omega is equals to angular displacement by time taken. So this is we call angular displacement divided by time taken. Then SI unit for this radians and this is second. This is called radians per second. That's all. Hope you got that. There's a question we got from there is a once again in the fifth question a little bit there is a query over there. In this question, what is given? Just look at carefully over there. X equals to ay plus b tan cz, where cz, tan cz, we know that the dimension cannot be applied for trigonometric function. So these are the dimensionless physical quantities. Remember, these are the dimensionless physical quantity. Then dimensions of b, this dimensions of b is always equals to which physical quantity here? This is ay. So this is equals to what? Ay. Then dimension b is equals to what we get? Ay. We have to find the value of y. Y is equals to what we get? B by a. This is one we get. Similarly, there is a dimensions of ay is always equals to dimensions of ay is always equals to how much quantity it is? X. Then if it is equals to x, then there is an y comma b by a. It means option number 3 is the correct answer. No, there is no questions which is going to be asked in that. So hence, only in the board level we can see the questions, such type of questions over there. Okay. Hope you enjoyed. Thank you.